So, good evening, students. We are going to see the analysis of a composite wall through heat transfer rate, that is convection and conduction. So, there are three materials given in this composite wall, that is K1, K2, and K3. These three materials, convection rate is given, that is 25 watt per meter degree Celsius, and then 30 and 70. Then the temperature at the outer side of this wall is given as 20 degrees Celsius, that is given by T0, and then the convection heat transfer takes place in the inner surface, that is this side, this surface of the wall beside the K1. It is H given is 30 watt per meter square degree Celsius, and the temperature given is 800 degrees. So we have to go for this analysis. First of all, you have to open ANSYS mechanical APDL. So this is a classic mode of ANSYS. So I am using here a student version of 2019 R3. So we are going to wait for some time. It will take a minute to start. So here we go. Now go to the preferences first, and in that preferences you have to go for, there are different types of analysis. You have to select the type of analysis we're going to solve. It is, this is a thermal type, so select that thermal one, select OK. Then go to preprocessor. In that we have to define the which type of element you are going to use. So go to add and add, instead of using the link element as we solved in the previous problem, because in the previous problems of composite walls we are not have convection and the heat transfer rate value. So for that now we required solid type, that is quad 4 node 55 plane. So select that element and close it. So for this element we don't require rail constant or the area going to give to this element. So first of all we will give the material properties. So three materials are going to use, that is K1, K2, K3. That value is given of convection rate is 25, 30 and 70 respectively. So for that first material, thermal conductivity isotropic. So in that first one is 25, select OK, K1. Next go to second material, add the second material. It is of, again same method, you are going to use 30. This will be for K2 material, and for K3 material it is 70. That's it. This all the material properties we have given. Now we have to create the model. So for that go into the modeling section. In that create, so previously we used key points to create the models, then lines we have used for beams, and nodes and use of elements we have used in the previous problems we have solved in our practical sessions. Now in this type you have to use area, because we have used a solid type of element type. So in that we are going to use a rectangle, because our this component or this wall, composite wall, is of a rectangular shape. So first K1, K2 and K3. So H value is 0.3, that is the width of this wall is 0.3 meter, then 0.2 and 0.15. Okay, so for that by two corners, this X and Y will be the starting point and ending point, and width and height you have to add. The first is 0 0. If I'm not taking this or keeping this blank, it will take as a 0. by default. And go to this width. Width is 0.3 meter and the height is 1 meter. So apply it. So this will be your K1 section. Now we have to start from this point. So for that I will take this 0.3 and then initial position of that, and then width will be 0.2 meter and height will be the same 1 meter. Apply it. And again from this point, so we are going to add this 0.3 plus 0.2, that is equal to 0.5 meter in the x direction, and width will be 0.15 and height will be the same 1. And now for the last one we have to select OK. So I have created the model of K1, K2 and K3 in respect to their sizes given in the problem. Now I'll close this area. Now for this we have to add or glue this area. So for that go to operate. In operate, booleans, booleans in that glue, and in this you have to use area to glue this three uh, area given K1, K2 and K3. Select OK. So after selecting this gluing these areas, now I'm going to use meshing. So in that meshing, go to mesh attributes and default attributes. You can see this in the first type is elemental type, that is we have used one plain 55, that is chord 4 node 55 of solid element. Then we have used this material properties 1, 2 and 3, that is 25, 30 and 70 watt per meter degree Celsius. So first we are going to use the for first material, that is K1 25. Okay, so select OK. Now first of all I will go to this mesh, and in that size control, in that control I'm going to define the meshing size of each element. So in that go to areas, in areas pick areas and select all these three areas. Okay, and I will give the value of size element edge length. All is divided into 0.05. So this discretization of this meshing will takes place by 0.05, okay, of this area given or defined. Now I will go to mesh. In this mesh I have to use this area. In that free meshing and map meshing, in that I'm using free meshing. Select this first one and select OK. So it will mesh the K1 area and it is guessed mesh by 0.05 in length. Now I will again go to this mesh attribute, default attributes. In that I will change the material properties to number 2, and then again I will go to mesh and select the area free meshing, and select the second type, second material, that is K2 material. Again it will mesh. Then again we are going to go for mesh attributes. In that third material, that is material number 3, having 70 value. So go to mesh again. In that mesh again free meshing and select the third and the last one for K3. Okay, so all this K1, K2 and K3 gets mixed up and meshed in free meshing. Okay, after meshing we have to define the boundary condition to this. So what are the boundary condition is that this boundary condition is given, that is first we have to give this temperature and then we have to give this convection values. Okay, so these are the two boundary conditions we have to define to this problem. So go to loads, in that loads define loads, apply loads, in that thermal, and give first temperature. So temperature online, select this last one, and what is the temperature given? It is 20 degrees Celsius T0. So it's a constant and it is not going to change. So 20 constant value temperature, and we have to select OK. So it's defined here. So the outer surface of the wall getting the temperature 20. Okay, now convection is given, convection value that is line on this line, what is given 30. H is given is, that is the coefficient of convection coefficient. So for conduction we are using alpha. In this case we are going to use H, that is given 30 watt per meter square degree Celsius, and temperature of bulk temperature is constant up to 800 degrees Celsius. So apply this, select OK. So we have given the boundary conditions to our problem. Now we're going to solve this. Go to solution, solve, current LS. So select OK. It's taking too much time. So solution is done. Now in the post process, general post process, we have to get the results of your problem. That is counter plot, nodal solution. In that nodal solution you have to select nodal solution, DF solutions. In that, nodal temperature acting on this component or on this composite wall, select OK. So this is the answer, but the maximum temperature is 319.789, and the minimum, that is this side, 20 degrees Celsius. So it get distributed by convectionally. If we use conduction, the maximum temperature will be 800, then it goes on reducing to this last level, but in this case the heat transfer takes place by convection. So 319 is the maximum temperature. And to list this result, go to list result, nodal solution, and give solution, nodal temperature, and select OK. So this will be your temperature value. So it is acting as I am discretize this composite walls into number of parts, so it is going to divide at this. So now the maximum temperature is 390.79. This will be the answer and your solution and assignment for the fifth assignment I have given for you. So for that you have to take the snapshot of this, and then the list results. Only take this the list result, only take the last starting this this part, okay, and this whole part up to the here, and the last part, okay. Don't take too much of this. So just take the starting points, that is node number 79, then next at node number 157, then next, and this way you have to take the answers from this, keep that answer, and remaining one you have to delete it up, okay, and take the print and submit it after the next practical, or in the next practical we're going to conduct. So for stay tuned for the lectures also, I'm going to upload on YouTube. So this will be your assignment number 5, second problem. The first problem I have taught in the college only in your practical session. So thank you for listening me.